Let us see an interesting question from analog VLSA interview. This RC circuit is considered to be very important in terms of analog VLSA interviews. So in this question, one 5-volt source is given as constant and another 5-volt source is given as step. Step means at time t is equal to 0, it is 0, and after that it will be 5 volt. This is what step means. So let's try to analyze this one. First we will see before this area what is the circuit at this voltage will be 0. Let's say the circuit that's less than 0 will be, it will attain to steady state. This 5 volt will be here and it is 1 kilo and it is 1 kilo, so the current flowing through it will be half of that, means 5 divided by 2 kilo will flow, and the voltage divided by here it will be, let's try to change the color, and it will be 2.5 volt, right? Then these two are also open circuited, and here also it will be 2.5 and same 2.5 will be coming here also, since all are in parallel. This is the circuit before this step input was given. At this point it attains the steady state. At steady state, capacitor will act as a open circuit, so it is open circuited. Now at time t is equal to 0, what will happen we will see. At time t is equal to 0 plus, the circuit will be, if you see here earlier, here the voltage is 2.5 volt, right? 2.5 volt, and here also it's 2.5 volt. The voltage at this node will be 7.5, but here this node will be 2.5. So here the KVL itself is, so but capacitor has a property that it cannot simultaneously change its voltage. So here we have a contradiction. So here the capacitor can't able to change its voltage, and the total voltage here is 7.5, and at the same node, this is the same node, right? At the same node we have 2.5. So it's like contradicting, both are contradicting each other. Now but there will be other case for capacitor. If a infinite amount of current I is equal to infinite passing through the capacitor, means capacitor can change its voltage instantaneously, means it can change its voltage instantaneously only in the case of infinite current. Impulse current means impulse current. So here there will be a impulse current passed through the capacitor in this direction. So now instantaneously, this is wrong, it can't be 7.5, it will be like, now due to instantaneous current flowing through this 5 volt battery, the charge distribution Q initial will be equal to Q final. By this we will get the charge distribution, and the voltage of this in this direction it will be charged to 2.5, and this capacitor will be charged in this direction by 2.5. So the voltage will be, here it will be 0 volt and here it will be 5 volt. Okay, now after that the capacitor will try to need to go to steady state. Let's see at time t is equal to infinite what will be the circuit. At time t is equal to infinite, the circuit will be something like, let me draw the circuit first. It will be open circuited and 5 volt will be here, and we have another open circuit here. This is the circuit at t is equal to infinite. Now the total current will pass in this path only, so the voltage drop will be 2.5 volt here. So this node has 2.5 volt and this node has 2.5 volt. Okay, this node also has 2.5 volt, means all this completely is a single node. So the voltage drop across in this capacitor will be 2.5, and the voltage drop across this will be 2.5, but in opposite direction, means plus minus. Now let us see how this like how graphs we can draw. First let's try to draw graph for VC1 graph. You will see this is VC1, let's say VC1. Okay, for VC1 the graph will be, it will reach let's say it reaches the steady state before t is equal to 0 to 2.5 volt. Let's say this is 2.5 volt. Before t is equal to 0 we saw right here, this 2.5 volt it will reach, and at t is equal to 0 it is instantaneously going to, let me change the color, it is instantaneously going to 0 volt, and then at t is equal to infinite it is going to minus 5, means it is settling. Minus 2.5 it's reaching by after some time. Now it will be reaching by tau, it will get settled by tau. Tau is these two are parallel with C1 C2 are also parallel, means they will get added. This is the tau, you can calculate the tau value. Now let's see graph for C2 VC2 also, VC2. Let's see VC2 graph. It will also from infinite time, after before time t is equal to 0 it will get settled to 2.5 volt, and after that instantaneously it will reach to 5 volt, and from there it will again discharge to 2.5 volt. 2.5. This is how it will retain its position to 2.5 volt. Now let's see current graph. Let's say you have current in this path, means same current here, whatever. Let's say this infinite current will be I. It will be, maybe it will be start somewhere and get settled to 0. Means it will come like this in this manner. It will get settled and it will come to 0. Okay. Let me draw the other graph. It will be something like, it will be settled to 0. Then at this instant, at this time t is equal to 0, it will be having a infinite huge amount of pulse, huge amount of current will be passing through it, and after that it will be 0. This is how we have to analyze this circuit. That's it.